Good morning. This section I will be discussing the classification of chromatography based on the operational technique that is used. So, one main scheme of classification based on the operational technique adopted to bring the differential distribution or migration of the component in a sample mixture which results in their separations are two types. One is the plane chromatography, other is the column chromatography. So, as we discussed in the previous section basics of the chromatography, we have the separation of the chromatography based on the physical state of the mobile phase and stationary phase used. So, main classification was into a liquid chromatography and gas chromatography. So, these two type of the technique we can further divide it into plane or column chromatography. So, basically it is related to the liquid chromatography we can use in a plane chromatography mode or we can use in a column chromatography mode. On the other hand, the gas chromatography can be used only for the column chromatography mode. Column chromatography is generally used to describe all chromatographic techniques which employ a column of solid adsorbent or liquid coated over the solid as a stationary phase. That means stationary phase is attached to a suitable matrix which is an insoluble support packed in either glass or metal column, and the mobile phase is passed through the column by gravity or pump. Therefore, liquid solid chromatography and liquid liquid chromatography are examples for the column chromatography. Plane chromatography, the chromatographic techniques which employ a flat, relatively thin layer of material that is either self-supporting or is coated on a support like a glass plate, or we can have a metal sheet or plastic surface, or in some cases it can be a filter paper as well as the stationary phase come under the plane chromatography. Here the mobile phase is a liquid that moves through the stationary phase by capillary action. Plane chromatography can be further classified into two according to the nature of the stationary phase what we are going to use. The one is the paper chromatography, that is most important, and the other one is the thin layer chromatography. As I told, the one classification is the paper chromatography. In paper chromatography, it is a special field of liquid chromatography. In this technique, the stationary phase is a film of liquid. For example, the water adsorbed on a paper mat usually made up of highly purified cellulose. Instead of the adsorbed moisture or this water, we can use some of the organic solvents that is adsorbed on a filter paper that can be also used as a stationary phase. Here the mobile phase is another liquid which percolating over the paper, or we can say the stationary phase. Water, organic solvents or buffer can be used as a mobile phase in the case of the paper chromatography. Successive equilibration or the repeated movement of the components between the stationary phase and the mobile phase will set up a dynamic differential migration of the components which will result in their separation according to their nature. So, paper chromatography is considered to be the simplest and the most widely used chromatographic technique because of its applicability to isolation, identification and quantitative determination of the organic and inorganic components. The practical requirements for a paper chromatography setup includes the stationary phase, that here is we are using as a paper, and the application of the sample on the stationary phase, and of course we must have a mobile phase, then developing technique for the chromatogram, and we have the detection or visualizing of the separated sample spots. For stationary phase, Wattmann filter papers of different grades can be used. So, different categories I have given here is, one is the modified paper. For example, we can have acid or base washed filter paper or glass fiber type paper, we can use it as a stationary phase. Another one is the hydrophilic paper, paper modified with methanol, formamide, glycol or glycerol or any other polar organic solvents. Another one is the hydrophobic paper made by acetylation of the OH group in the cellulose to make it hydrophobic in nature. Factors governing the choice of the filter paper that we are used as a stationary phase are nature of the samples and the solvents employed for the separation, whether we are using the separation for a quantitative purpose or a qualitative purpose, and the thickness of the paper used here. First step is the preparation of the paper or the stationary phase. As we know, cut the paper into a desired shape or the size according to the size of the chromatogram jar. Draw the starting line by using a pencil across the paper 5 cm up from the bottom edge of the paper. On the starting line, marks are made at 2 cm apart from each other for the sample spot. The sample is to be applied is dissolved in a mobile phase, that is a suitable solvent, and applied as a small spot on the starting line using a capillary tube, or we can use a micropipette as well. So, as you can see, the spot is allowed to dry and placed in a chromatogram developing jar, or we can say chromatogram developing chamber. The chamber will consist of a support for hanging the paper, a solvent trough, and a airtight glass tank which is saturated with the mobile phase or the solvent what is going for the separation. The paper which containing the sample spot will suspended, as you can see in the figure, in the glass tank with its lower end just dipping in the mobile phase in such a manner that the spotted positions are above the solvent level, or we can say it will be clearly visible, or we can see the spots what we are put on the paper. So, the solvent will rise up due to the capillary action, and it is allowed to run 2/3 of the paper height for a better and efficient separation. So, there are different modes of developing the chromatogram by using the paper chromatography. The one is the most commonly used is the ascending development. As I explained before, just like what we here we can have the solvent flowing by the capillary action against the gravity from the bottom of the paper to the top of the filter paper. Here the sample spot is at the bottom of the paper, the mobile phase is simply flowing up of the paper. Another type is the descending development, is carried out in a special chamber where the solvent holder is at the top of the paper. Here the spot is kept at the top of the paper and the solvent flowed down the paper in order to develop a chromatogram. The other one is the circular or radial development. Spot is kept at the center of a circular filter paper or the stationary phase what we have taken here. Here the mobile phase flow throughout a wick at the center of the filter paper that we made, and it will be spreading in all direction uniformly, so we can get a nice separation of the individual component on the circular paper. The other one is the two-dimensional development. In this method, firstly a chromatogram is developed in one direction and a separation is carried out on the same paper in the another direction. So, it is just like a two-dimensional chromatography. This two-dimensional development result in the separation of the component or the spot in first chromatogram into further components, or the further here the same mobile phase or the different solvents can be used for the second dimension separation. So, here in this first case two-dimensional development, first development is the separation of the mixture into individual component. In the second case, these individual components what we are got the separation from the first dimension is further separated in by using a different mobile phase or a combination of the mobile phase what we can have. So, in this way we can get a two-dimensional separation of by using a paper chromatography. After the mobile phase has moved through a certain distance for a certain time, what we do is we will taken out the paper from the chamber and we will try to mark the solvent front, how long the solvent has moved along the paper. Then next section we will be going to dry the paper. So, the paper can be dried either by the cold air, or we can use the hot air as well. So, depending upon the volatility of the solvent what we are using here, we can use either hot air or cold air. So, something like a simple hair dryer can be used for drying the filter paper what we are going to take out from the chromatogram jar. For detecting or visualizing the sample spot what we developed on the paper, if the sample mixture and the components are colored compounds, it is easily to detect or visualize the individual components that what we got the separation on the filter paper. For the colorless substance, physical and chemical methods can be employed to detect the spots. For the physical method, for example, we can use a iodine chamber method, UV chamber for the fluorescent compounds, etc. In the chemical methods, what we do here is spraying the chemical reagents which can convert the colorless components into a colored compounds. For example, we use the ferric chloride for the phenolics and tannin identification, or we can use the ninhydrin acetone for the amino acid separation or identification. So, all these methods what we used here, either a physical method or chemical method, that are called the direct methods for the detection. By simply taking out the paper, we can spray some of the reagents, we can simply visualize the sample or the individual component that is got the separated on the filter paper what we are going to use as a stationary phase. There are the other things what we can call the indirect method. Here the separated individual sample spots what it is developed on the filter paper, we can cut into small pieces. So, or we can say we are going to divide the individual spot into further, then we can take the spot into another solvents or mix it with another solvent, we can dissolve the spot into a different solvents, and we can just analyze those for the further analysis, either by using the spectroscopic techniques or we can use some of the electrochemical methods as well. So, that is why we are calling this is an indirect method. We are collecting the individual spot and dissolving in a suitable solvent, and we are going to further analyze that one by using the different analytical or identical methods. In paper chromatography, the results are represented by the retardation factor or called RF value, which indicates the movement or migration of the sample component relative to the solvent front. So, it can be given as by the equation RF value of a component is equal to distance travelled by the sample component divided by distance travelled by the solvent front. There are different factors that affecting the RF value of the components. Here I listed many of the factors that will be affecting: the temperature, purity of the mobile phase used for the separation, the quality of the paper, adsorbents, impurities present in the adsorbents, chamber saturation technique, method of the drying and development what we used, the distance travelled by the sample components and the solvent mobile phase, chemical reaction that will be going to happening between the components that to be separated, and pH of the solution as well. Application of the paper chromatography mainly includes in the separation and identification of the drugs, separation of the carbohydrates, vitamins, antibiotics, proteins and etc., and also the identification of the impurities present in the sample. The main advantage of the paper chromatography is that the technique is very simple, rapid, inexpensive and have an excellent resolving power for the separation. Another type of the plain chromatography is the thin layer chromatography. It is also one of the simplest, fastest, easiest and least expensive of the several chromatographic techniques used in qualitative and quantitative analysis to separate the organic compounds and to test the purity of the components. Thin layer chromatography or TLC can be defined as a method of separation and identification of sample mixtures into its individual components by using finely divided adsorbent solid or liquid spread over a glass plate and using another liquid as a mobile phase. So, TLC is a form of the liquid chromatography. Like paper chromatography, it consists of a stationary phase and a mobile phase, and analysis is performed on a flat surface under the atmospheric pressure and temperature conditions. When and where we can use the TLC? So, regarding the sample, if the sample is non-volatile or less volatile, we can use the TLC. Or if the sample destroys some of the instrumental techniques, just like a column chromatography, for example, we can have a gas chromatography or we can have a HPLC or liquid chromatography. There we can't use these type of the sample. We can simply separate or we can simply identify the components or we can simply separate the component in such a complex mixture by using the TLC. Cases where the mobile phase chosen for the separation of the such a component will destroy the column or the instruments, we can also use the TLC as one of the efficient separation technique for the separation of the component in a complex mixture. Or if you have some detection limitations or the components cannot be detected by the GC or LC, we can also go for a TLC separation. Or in cases where we can have no source of the electricity or we do not have a advanced instrumental setup in order to get a separation, we can simply use the thin layer chromatography as an efficient separation technique for the identification of the individual component in the system. So, the principle of the TLC or thin layer chromatography, it is based on the principle of the adsorption chromatography or a partition chromatography, or we can say some cases they are saying it is a combination of the adsorption and a partition depending upon the nature of the adsorbent, its treatment and the nature of the solvent employed for the separation as well. So, just like in any chromatography, the component with more affinity towards the stationary phase will move slower compared to those have less affinity towards the stationary phase, or otherwise we can say it will simply float with the mobile phase what we are going to use. So TLC setup is similar to the paper chromatography, just what we discussed now. So except that a thin layer of some of the inert material like aluminum oxide, magnesium oxide, silicon oxide, etc. is used instead of the paper as the stationary phase. So if you look at the working of the thin layer chromatography, as we know, stationary phase is slightly different from the paper chromatography. Here what we do is a slurry of the adsorbent in a suitable liquid chosen as the stationary phase is spread over a flat and uniform plate. The chromoplate thus prepared is spotted near its edge with the solution containing the sample mixture. So it is placed in a slanting manner, so that is the stationary phase or the plate that is placed in a slanting manner in a glass tank that containing a thin layer of the solvent such that the sample spot are just above the solvent level. The tank is closed with a lid. So the thin layer of the solvent or the liquid here we use as a mobile phase for the separation of the individual components. So the mobile phase ascent by the capillary action will take the component at different rates, results in their separation, and the solvents spots within few minutes we can get a nice separation of the individual components. The plate is then taken out, solvent front is marked just like what we have done in the paper chromatography, and we are going to dry the thin layer what we have taken out from the chromatogram jar. Like in a paper chromatography, if the spots are not colored, suppose the components or the mixture is itself it is not colored or the individual components are not colored, either we can use a physical method or chemical method for the identification of the individual spot that is separated on a thin layer plate. Here one advantage of the TLC thin layer chromatography compared to the paper chromatography is that you can scrap off the spot and can be analyze it further. For example, in the case of the paper chromatography, I was discussing about an indirect method. We are going to cut the paper. Instead of that one, we have given a nice adsorbent, a slurry or paste of the stationary phase on the plate which has taken as a supporting material. We can scrap the individual spot and along with the stationary phase, and we can dissolve it in a suitable solvent, and we can analyze it further by the spectroscopic techniques or the electrochemical method for the exact identification of the individual component what we are going to use. A comparison of the RF value, just like a paper chromatography, here also we can use the comparison of the RF value of the different spot that will tell you about the chemical nature or the nature of the individual component what we separated using the thin layer chromatographic techniques. Thin layer chromatography is mainly used to check the purity of the sample or in order to monitor the reaction, examination of the reaction, whether the reaction is complete or it is going on, or whether it is a starting material or how many product it has formed, etc. Then identification of the individual components again in biochemical analysis, in pharmaceutical industry, in separation of the multi-component pharmaceutical formulations, etc. It is also employed in the food and cosmetic industry for the separation and identification of the individual component that present in the system. So in this section, we discussed about the classification of the chromatography based on the technique, operational technique that is employed. So we were talking about two types, that is the plain chromatography and other is the column chromatography. Then we have gone through the details of the plain chromatography. It is further classified into two, that is the paper chromatography and the thin layer chromatography. So as you can see from the explanations, what we used here is the very simple technique. So by using the simple technique, just like we have one side in the case of the paper chromatography, we have a paper as the stationary phase. In the other case, thin layer, it is just like something coated over a support or a metal sheet or a polymer sheet or a glass plate, etc. So as you can see from here, this is a very nice and simple experimental setup that you can do for the identification or separation of the component. So in a simple chemistry lab or analytical lab or with using a limited experimental setup, you can set up a thin layer or paper chromatography for the separation of the individual components. So again, as you can see, just like a paper chromatography, we were doing a two-dimensional separation. In one side, we have done the separation of the components or separation of the mixture into different components according to their particular nature. Then again we are going to do a separation on the same paper in another direction, that is we call the two-dimensional chromatography. So you can see this is the simplest and the fastest and easiest, after all we can say very cheap technique for the separation of the complex mixture into its individual components. I guess you enjoyed this section. In the next coming section, we will be going to another type of the classification or most commonly used instrumental methods of the chromatographic separation. Thank you for listening.